Hello and welcome everyone to this new playlist that I have started on the topics related to geophysics. The first topic that I will be sharing in this playlist is about vertical seismic profiling, which is also known as VSP, and we will look into its data analysis. So these are some of the topics that we will cover or see in this presentation. We will generate a synthetic data initially, a zero offset VSP data. Then we will try to apply some amplitude correction to this data to account for the spherical divergence and absorption effect. Um, and then we will look into time depth relation and velocities. We will also see how to separate downgoing waves and upgoing waves in the VSP data. Then we will apply predictive decon to this data uh, to suppress multiples. And then on time corrected upgoing wave, we will um, extract corridor stack, the final output, which is called the corridor stack, that we could compare with the surface seismic and well log data. What's the difference between VSP and surface seismic? On the left, we see a typical surface seismic setup. We have source and receivers both on the surface. And from the source, the wave propagates into the earth and then it gets reflected back and received at the receivers at the surface. And this is how we see the reflection data and we analyze that data to get information about the earth structure for different purposes. On the right, we see VSP setup. So we have a well in this case. So we will use some available well. And then we will deploy geophone arrays in this well, inside this well. So instead of the surface, we have the receiver inside the well. And now the source emits the waves and that propagate into the earth and then they get received by these receivers inside the well. So there are certain advantages that VSP configuration has over surface seismic. One of them is that since the wave travels through the LVL only once, which is the low velocity layer, LVL, so it gets less attenuated. So still the frequency content is relatively higher as compared to surface seismic. Um, in other case, we also measure both downgoing and upgoing wave fields in VSP data, and we could design efficient deconvolution operator and we could identify and eliminate interbed multiples from VSP, and VSP also helps in true reflection amplitude calculations. Um, and one other important advantage of VSP is that we could get the time depth relation and also an estimate of interval velocities from the VSP data, which can be very useful. All right, so let's look into the synthetic data generation. So on the left, we have our experimental setup. So we have a four-layer model. So the first layer has a velocity of 2800 meter per second, and the second layer has a velocity of 4000 meter per second. So we did this to um, create a relatively strong reflector. Um, and we have 40 receivers placed in a vertical well, um, and the receiver spacing is 15 meters here. And To the right, we have the generated synthetic data, and you could see the direct arrivals coming first, and then we could only see the upgoing uh, reflection from the first interface, so that's the stronger one, and the downgoing multiple as well. And rest of the data is there, but we cannot see it. So in the next slide, we'll apply some amplitude correction to see this data. On the left, now we have the same data as showed in the previous slide, and after applying some gain correction, amplitude gain correction, we could start seeing some data. So now we can see that we have the direct arrivals here. Then we have some reflections, upgoing reflections, and or upgoing waves, and then we have downgoing multiples, and we also see some upgoing multiples in the data. And once we do this amplitude correction, so we try to pick the first arrival, the direct arrival, and we do so using some manual approach or automatic algorithm. So here I used an algorithm based on Akaike information criterion, which is also known as AIC, in combination with the correlation picker. Um, so we pick these direct arrivals, and then we could use these and direct arrival picks or first break picks to estimate the interval velocities. So here I am plotting the interval velocity estimates from VSP, and also on top of that I'm overlaying the model that we used to generate our synthetic data. And as you can see, they are pretty good estimates. Then the next task is to separate the downgoing wave and the upgoing wave for further analysis. So here we see 6 panels. So starting from the left, we have our combined wave field. So that shows the downgoing and upgoing together. So next, what we could see, we could subtract these peak times so that everything is aligned at one point. So we could see the direct arrivals are all lined up horizontally or aligned horizontally, and the upgoing waves we could see as well. So now there are different ways of separating downgoing from upgoing. We could apply FK filtering, we could apply median filtering, or we could apply uh, SVD or eigenimage filtering techniques. Here I'm applying eigenimage filter, and now we could see the downgoing wave field, which does not show any significant upgoing remnants, and this is the upgoing wave field that we extracted from the combined wave field. And now once we correct the travel time, so we get the same move out as the left panel and the downgoing wave field and the upgoing wave field. So the next step is to remove or suppress any multiple energy present in the data. So for that, we'll be using predictive deconvolution. So these are the results here. So downgoing wave field, first panel from the left, and then we see deconvolved downgoing wave field where we don't see the multiple energy. Um, and then we have the upgoing wave field. So we use the downgoing wave field to design the deconvolution operator, and then we apply that operator to the upgoing wave field to remove the multiples. And we can see that this multiple here um, has been successfully suppressed or uh, eliminated from the data. All right, the last step in zero offset VSP processing is to generate these corridor stacks that we could use to compare VSP data with the surface seismic data and for different purposes to identify lithology or to see whether some multiples are present, still present in surface seismic, and we could improve surface seismic processing using that. So this process is also very simple. So now we uh, convert the upgoing to two-way travel time. So now we have a flat reflector here. Um, and now we could see we have three reflectors. Uh, then we only keep the data very close in a narrow muted window near the first break peaks, and that's what we see in the center panel or the middle panel, and then we stack these traces and we get one single stack trace. So we display multiple copies of the same trace together so that it's easier for us to compare it with well logs or surface seismic data or synthetic log that we generate with from well logs and surface seismic data. So this was all about VSP processing. I hope you liked it, and please leave a comment if you want to see more topics, related topics in geophysics, or if you want to see details on a specific topic, uh, yeah, please let me know. And thanks for watching. And don't forget to subscribe my channel. Thank you.